So in this problem, we are asked to create an equation using our y equals mx plus b format, given just a graph. Now I've created a rough sketch of this graph. If you're following along with the practice set, please have it in front of you so you can see with a little bit more accuracy. But I've just got this sketch basically up as a frame of reference. So in order to complete this equation, we've got to break it down, and basically we're looking for two things. We're looking for our y-intercept value, and we're looking for the slope of the line. All right, so I'm going to go ahead and rewrite, and I'm going to leave those spots blank until we've identified them. So y-intercept is usually the easiest to find because, especially for a graph, you're just looking for the spot where the line crosses the y-axis. So in this case, it crosses at 0, 3. So our y-intercept is 3. All right, slope takes a little bit more work because to find the slope, we need to find the change in y over the change in x. All right, because remember, slope is the rise over the run of our line. And so we need to identify a y2 and then subtract it from a y1 and then x2 minus x1. So it actually, we can use whatever points we would like on this, but I'm going to use 0, 3 as my x1 and my y1. And I'm going to use 1, 5 as my x2 and my y2. So I'm going to substitute those values in. So I'm going to get 5 minus 3 over 1 minus 0. And you can kind of see why I chose the values that I chose. And so what we end up with is 5 minus 3 gives me 2. 1 minus 0 gives me 1. And so my slope is 2. And so I get y equals 2x plus 3. Now, I want to go ahead and verify that, and I can verify it pretty easily using this third point. Because if x is 2, my y should be 7, but let's verify. 2 times 2 is 4. 4 plus 3 is 7. And so this formula works with this point as well. So my answer is y equals 2x plus 3. All right, so again, we are creating an equation using our y equals mx plus b format. This one's going to be a little bit more challenging for a couple of reasons. Now, the first and most obvious reason is we don't have a y-intercept value that we're given. We're actually going to have to work backwards to find that. We're going to have to find our slope first. All right, so, and we can do that. You're just going to have to trust me on this one. So if we look at our data table, all right, we can actually see how the slope, how the rate is changing. And it's pretty obvious to see that every hour, the number of shirts goes down, or excuse me, the number of tickets goes down by 3,000. If that rate is constant, then at 0 hour, what would the starting tickets have been if at hour 1, the tickets were 12,000? Well, hopefully you said 15,000. So hang on to that rate of change because we're going to use that in just a minute. But let's go ahead and I'm going to leave a little bit of space this time since the numbers are a little bit bigger. But our y-intercept is going to be 15,000. All right? Because the rate of change is 3,000, right? Or is it 3,000? The change, and what we're going to do is we're going to go ahead and do our slope formula. So remember, slope is change in y divided by change in x. Okay? We're going to use, for our y2, we're going to use 9,000. For our y1, we're going to use 12,000. For our x2, we'll use 2. And for our x1, we'll use 1. And so what we're going to see here, and hopefully you're starting to see it already, is 9,000 minus 12,000 is negative 3,000. And 2 minus 1 is 1. So our slope ends up being negative 3,000. Now that makes sense if you think about it because the number of tickets is dwindling. It's getting smaller as time goes on. And so our slope should be negative, because if you start with a big pile and it's slowly getting lower and lower and lower over time, then we've got that downward slope if we were to graph this. And so our equation is y equals negative 3,000x plus 15,000. Don't get tripped up on this, because a lot of people will see that 12,000 as the first number in the data set and put that down. Well, that's not when x is 0. That's when x is 1. So we've got to use that. Hey, if this was 3,000 or negative 3,000 when x was 1, when x was 0, it would have been 15,000. So this one was a little bit trickier, had a few extra elements into it, but if you understand how all these numbers work together, you should be able to solve it. So this problem is pretty straightforward. We have to create an equation with our y equals mx plus b format. We are given two pieces of information: the monthly fee of $39 and then a registration fee of $45. Now, if it's a monthly fee, that's a rate. So that's our rate of change. Every month, we pay that $35. Every month, we pay that $35. Whereas the registration fee, that's a one-time fee that we only pay once. So thinking it in terms of our formula here, or excuse me, of our equation, then that monthly rate, every month we pay it, that's a rate. Our monthly rate is a rate. Imagine that. So our slope would be 35 for our monthly rate, x, plus that one-time registration fee of $45. This one pretty cut and dry, pretty simple, but you still have to understand what that y-intercept number represents. Remember, that's a constant number that doesn't change. So in a real-world situation, that's a service fee or a one-time fee or a materials charge. Whereas our m, our slope, our rate of change, that's a rate number. So much per hour, so much per month, so much per mile, so much per pound. All right, you've got to understand the difference between those two numbers in order to read these problems correctly. All right, so in this question, we are given a graph, and then we're asked to construct our y equals mx plus b equation based upon that graph. So a couple things we want to look for. We want to look for the y-intercept, and then we want to look for some points where we can identify the slope. So I'm just going to identify 2 points which should help me solve this problem pretty quickly and efficiently. All right, so I'm going to identify the y-intercept, and then I'm also going to identify the x-intercept for my second point. So our y-intercept is 3, so I'm going to go ahead and rewrite. I'm going to leave my slope blank, but I'm going to write 3 as my y-intercept. And then I've got to find the slope. Remember, to find slope, we have change in y divided by change in x, which is y2 minus y1 over x2 minus x1. And in this case, I'm going to use 6, 0 as my x2 and my y2, and 0, 3 as my x1 and my y1. So I'm going to have 0 minus 3 over 6 minus 0. And so I'm going to end up with negative 3 over 6, which will reduce to negative 1/2. And that's my equation. Now, because my slope is negative, I see that I've got this downward angle on my slope, which is accurate. That's what I should have. So once again, we've got a graph, and we have to, using the points on that graph, we have to create our equation, our linear equation, in the y equals mx plus b format. So I'm once again, and again, you could plot any 2 points upon this line, and if you've got the hard copy printout, then you could identify some other points. But I'm going to use the x-intercept and the y-intercept again, as I did in the previous problem. One, because the y-intercept is going to tell me exactly what b is, but also because when you're subtracting by 0, it's actually pretty simple. So I'm going to go ahead and rewrite over here. I'm going to leave my slope blank. And I'm actually going to, well, I can go ahead and put that there. All right, so my y-intercept is -6. So I'm going to go ahead and erase the plus sign and put -6 there. And now I need to find my slope. So remember, slope is the change in y divided by the change in x, which is y2 minus y1 divided by x2 minus x1. And again, I'm going to use my y-intercept as my x1 and my y1, and I'm going to use my x-intercept as my x2 and my y2. All right, so that's going to be 0 minus -6 divided by 2 minus 0. So because I've got minus negative, I'm going to actually end up with +6, and then 2 minus 0 just gives me 2. And so when I simplify that, my slope is 3. And so my solution is y equals 3x minus 6.